We talk to our computers all day, every single day. But have you ever stopped to think about how our ideas, our taps, our clicks, our commands actually get inside the machine? In this explainer, we're diving into the essential hardware that makes that whole conversation possible. Input devices.
This question is really at the heart of all computing. It's the very first step in any interaction we have with technology. Doesn't matter if we're just sending a quick text or, designing a whole skyscraper.
And this brings us to a really crucial idea. Thinking of input devices as our digital translators. They're the absolute essential link between us and machines.
So here's the key takeaway. These devices, they bridge the gap between our human world and the computer's binary world. They take our actions, a key press, a mouse movement, a spoken word, and they translate all of that into a pattern of electrical signals that a computer can actually process. It's this simple but incredibly powerful three-step flow. And it all starts with that first step, input. Seriously, without a way to get data in, the most powerful processor in the world is just a silent, useless box. Everything from writing an email to playing a game follows this exact sequence.
So if input is step one, well, that leads us to our first big problem. How do we give computers specific, really detailed instructions? How do we tell them exactly what we want them to do?
This very question led to the invention of the two most common input devices we use every single day. They've become so universal we barely even think about them anymore, but they are our primary tools for commanding a computer.
First up, the keyboard, our workhorse for text. Every single press completes a little circuit, and that sends a unique character code that tells the computer you've typed an A or a 7. It's super effective, but as a lot of us know, that repetitive motion can lead to health issues like repetitive strain injury.
And this is where the mouse became so essential. It solved the problem of navigating a graphical user interface, a GUI. Instead of typing commands, we could just point and click. The modern optical mouse, it uses a laser to track movement for really precise control. And because there are no moving parts like those old ball mice, it's also incredibly reliable. Okay, but what about things that aren't just text and clicks? Our world is filled with images and sounds and physical objects. That brings us to our next challenge. The solution was to invent a whole family of devices that could basically see and hear, capturing and digitizing the world around us, and turning all that physical information into computer-readable data. Now, what's really interesting here is the jump in dimensionality. A 2D, or what we call a flatbed scanner, that's perfect for turning a paper document or a photo into a digital file. But a 3D scanner, whoa, that takes it a step further. It shines a light over an entire object to record its geometry, its dimensions, creating a complete digital model that's used in everything from medicine to manufacturing. Just think about your smartphone for a second. It's a master of reality capture. It uses a digital camera to turn light into an image made of millions of pixels and a microphone to turn sound waves into digital signals. These two little input devices are constantly working to bring our world into our digital lives. Keyboards and mice are great, for sure, but they still create this kind of separation, right? A layer between us and the screen. Technology was pushing for an even more direct, more intuitive, and especially more mobile way to interact with our devices. The answer, and this truly revolutionized personal computing, was to just remove the middleman entirely. Why point at the screen with a mouse when you could just touch it? The solution was to turn the display itself into an input device.
So how does a screen actually feel your touch? Well, there are three main ways. You've probably used a resistive screen at an ATM. They're durable, they work if you're wearing gloves, because they rely on physical pressure. Your smartphone, though, that uses a capacitive screen. It detects the tiny electrical charge from your skin, which is why it's so responsive and lets you do things like pinch to zoom. And for huge displays, you've got infrared grids, creating an invisible sheet of light that your finger breaks, kind of like a laser tripwire. All right, that brings us to our final challenge, speed. How do we get information from a physical product into our device instantly without typing anything at all? The solution involves scanning patterns that act as a gateway to digital data, and you see them every single day on everything from your groceries to concert tickets. We've all seen these, right?
But they solve this information problem in very, very different ways. The barcode is the older, simpler technology. The QR code, on the other hand, represents a massive leap in capability.
Okay, so a barcode scanner, it shines a red laser on those black and white bars. The white parts reflect light back, the black parts absorb it. And this pattern of reflection gets converted into a simple digital code. They're simple, they're effective, and they completely revolutionize retail by automating checkouts and stock control.
But the QR code, which stands for Quick Response Code, took this whole concept to a new level. Instead of simple lines, it's a complex matrix of squares, scanned by a camera like the one on your phone. This design allows it to store way more data. But just how much more? Get this. While a typical barcode holds about 30 digits, enough for a product number, a QR code can hold over 7,000 characters. That's enough to store a full website link, your contact details, an event ticket, or even connect you to a Wi-Fi network all in one quick scan.
And ultimately, every single device we've looked at serves this one critical purpose. They are the translators, the messengers, the bridges that let us communicate what we want to our machines in a language they can actually understand and act on.
And that really is the core story here. The history of input is this constant quest to make our conversations with technology more natural, more seamless, more powerful. From typing, to clicking, to touching, and now talking, the way we interact will only keep evolving. Which really leaves us with the question, what amazing new bridges are yet to be built? Thanks for watching.